Good day everyone. Before we tackle about our second topic, let me introduce to you the reporters. Tanya Bia Serrano, Archie Gonzalez, Christian Lucas, Fernand Luis Domingo, Angelica Magno, and Razel Edrada. The topic for today's video is Solar Thermal System, also known as CSP, concentrating solar power. So what is the meaning of solar thermal system? Solar thermal power plants collects energy from the sun with the use of mirrors. The collected energy is being reflected or redirected to a tube. This causes the fluid to achieve high temperature. This fluid then transfers its heat to water, which becomes a superheated steam. This steam is then used to turn turbines in a power plant, and this mechanical energy is converted into electricity by a generator. So what does it mean? All solar thermal power plants collects energy from the sun with the use of mirrors, unlike the photovoltaic system na ginagamit to collect energy from the sun is the solar panel. So afterwards, makakollect ng energy, the energy will be redirected or reflected sa tube. Then, yung tube na yan is containing a fluid inside, and when it is redirected inside the tube, the fluid will receive or achieve a high temperature, which around 400 to 700 degrees centigrade. Yung init na meron sa fluid will transfer to water. After that, the water will evaporate and become steam, and that steam will make the turbine rotates and generates electricity. That's how thermal system works. So unlike nga daw dun sa photovoltaic na solar panel yung ginagamit, sa solar thermal power naman ang ginagamit is mirrors. So guys, let's move on naman sa 4 types of solar thermal system or CSP. So these are the 4. First one is parabolic trough, solar tower, linear Fresnel reflector, parabolic dish. So solar thermal systems have a 4 types, which is parabolic trough, tower, linear Fresnel reflector, parabolic dish. These 4 operates under the same principle. They only differ in the process of collecting sunlight and concentrating it to a certain point. So pare-parehas lang sila, pero nagkakaiba lang sila sa process ng pag-collect ng sunlight. Pero pare-parehas lang sila ng principle, which is makakollect ng energy from the sun using the mirrors. So let's tackle about the first type of solar thermal system, which is the parabolic troughs. These troughs, also known as line focus collectors, are lined up in a rows on a solar field and are composed of a long parabolic shape reflector that concentrates incident sunlight on a pipe that runs down at the middle of the trough. The collectors utilize a single-axis solar tracking system to track the sun across the sky as it moves from east to west to ensure that there is always maximum solar energy incident on the mirrors. The receiver pipe in the center can reach temperatures upward of 400 degrees centigrade as the trough focuses sun at 30 to 100 times its normal intensity. So what does it mean ba? Parabolic trough is able to hit the temperature upward of 40 degrees centigrade, and it can amplify density from 30 to 100 times. So this is how it works. The sunlight will hit the parabolic segment or yung mirrors po. Kung makikita nyo sa picture, ito yung blue part. And then after that, it will be reflected towards in the tube that is made out of glass. So yun po yung gitna na mukhang metal, pero yun po ay glass. So bakit nga ba glass? Kasi ang glass, kaya niyang tanggapin yung heat galing sa sun freely, but it doesn't allow to escape, as you can see in the picture. Yun nga po yung parang metal sa gitna ng parabolic trough. Inside that, Inside the tube, there is a fluid. The fluid inside the tube will have an elevated temperature that will reach 400 degrees centigrade. So, pag na-reach na po yun na po yung magiging para mapatakbo na yung or magamit na po yung na-collect na energy from the sun.
So, ngayon, pag-uusapan naman natin yung parabolic graph. So, yan, makikita natin dito yung parabolic graph basic diagram. So sa bandang dito, makikita natin yung mga blue mirrors. So, yung mga blue squares na yun ay mga curved mirrors na kung saan yung ginagamit para ma-reflect yung sinag ng araw. So, yung nakikita natin mga linya na, mga parang tube or may mga nakalagay na yellow lines, yun yung mga daanan or like doon nakalagay yung isang liquid na kung saan doon nare-restore yung init na nanggagaling, na magre-reflect mula sa sinag ng araw. So, ganito siya. So, once na nasinaga ng araw, yung mga curved mirrors na to, yun mangyayari naman doon is magre-reflect siya papunta sa mga tube na yan na may nakalagay na liquid. So, normally, umaabot yung mga liquid na nandiyan is umaabot ng around 400 degrees Celsius. So, after ma-reflect, magre-restore na ngayon yung init mula dun sa sinag ng araw, yung na-reflect na sinag ng araw. So, yan. After that, dediretso siya sa heat exchanger set. So, dito sa heat exchanger set, may kita natin dito, meron siyang fluid sa loob na doon usually nagdi-divide kung hindi siya totally naghahalo, but parang nagdi-divide doon yung init at lamig ng tubig or yun. Then, dito, once na dumaloy doon yung liquid na sobrang init, doon yung mahahalo doon yung liquid ay magiging steam siya. So, normally, pupunta siya sa steam turbine. After that, yung steam na lang galing doon sa heat exchanger set, doon manggagaling, doon yung kumbaga magpapagana ngayon doon sa steam turbine. Siya yung magpapaikot noon and yun yung magkakos para mag-generate ng electricity. So, makikita natin dito sa gawing baba ng steam turbine, meron dyan condenser and cooling tower. So, para saan naman yon? So, yung natirang steam galing doon sa steam turbine, dediretso siya ngayon sa condenser. So, ano nga bang ginagawa naman doon sa condenser? Doon naman, ginagawa na yung condensation na tinatawag or like turning gas into liquid. So, doon, nakita natin, masasala siya dun sa cooling tower. Then, after that, uulit-ulit siya sa simula. Kumbaga, after na doon, dediretso ulit yung liquid niya papunta dun sa pinakauna, which is dun sa sa tubo na yon. Then, mag-generate ulit siya ulit-ulit. Then, yung process niya is tuloy-tuloy lang din. So, let's go further dun sa mga ibang parts na pinakita din kanina dun sa parabolic graph basic diagram. So, this is what you call the heat exchanger. So, kumbaga, basic diagram lang to ng kung ano nga ba yung heat exchanger na sinasabi. So, dito, as you can see here, may kita natin yung blue will represent the fluid. So, yung red naman, siya yung mainit na tube. So, yun yung magkakos para magkaroon ng steam. So, bale, yung init doon, then magmimix siya. Not really mix, but yung init kasi doon, yun yung magkakos para mapainit niya rin yung fluid na nakikita nyo dito. So, once na naging steam na siya, lalabas na siya papunta sa left side dito. So, sabi nga dito, cooler before, yung nakalagay na arrow dito is cooler after. So, kumbaga, ngayon naman, ito nakalagay dito sa bandang upper left ninyo is yung hotter before. So, kumbaga, pumasok yung init dito sa tube na to, dito sa red na to. Then, yung paglabas ng liquid is also hot or like, hindi na siya literally hot liquid, but that will cause or magpo-produce siya ng steam. So, yun yung dediretso ngayon sa ating steam turbine. So, next naman natin dito is yung steam turbine. So, kung makikita natin dito, yung mga blades niya. So, kumbaga, yung blades na yan, bumabasa siya sa behavior ng steam na dadaloy dyan. So, iba pa yung turbine na makikita natin sa mga ibang power plant. So, kumbaga, for example, sa hydrothermal, diba, usually, iba yung itsura ng turbine doon sa turbine dito sa may steam turbine. So, doon naman, nagbabase siya sa behavior ng water. So, itong turbine naman na to, nagbabase siya sa behavior ng steam. So, kumbaga yung dadaloy doon na magpapagana ng ating mga generator. So, kumbaga, from steam turbine, nung dumaloy din yung steam, so, gagana na siya. So, yung blade na yan, iikot yan, ang magpapagana dyan yung steam na dadaloy, and then, mag-generate siya, yun yung magpapagana na ngayon sa mga generator.
Next is heat transfer fluid. In a solar thermal system, heat transfer fluid is a liquid or a gas especially manufactured for the purpose of transmitting heat from one system to another. Ano nga ba yung HTF? Ang HTF ay mga liquid na ginagamit sa mga sistema ng pagpapainit. Ito ay karaniwang ginagamit sa mga sistema ng pag-init at paglamig kabilang ang mga HVAC or heating, ventilation, or air conditioning system, mga heat exchanger at mga solar thermal system. Ang karaniwang uri ng heat transfer fluids ay kasama ang mga glycol, mineral oil, silicone oil, at molten salt. Sa mga solar thermal system, ang heat transfer fluids ay mahalaga dahil ito ay nagpapadala ng init mula sa mga solar collectors papunta sa iba't ibang bahagi ng system. So this is the question. Why use HTF instead of the direct system in which water is instantly turned into steam by the heat reflected by mirrors in solar thermal system or CSP? Before that, makikita natin sa naka-flash na picture na yung inside ng tube, ito yung heat transfer fluid. Nagkokolekta ng energy yung mga mirrors na galing sa araw. Pag nakasagap na ang mga mirrors ng energy or sikat ng araw, ire-reflect niya ito ngayon sa mga tube. Dahil ang tube na to ay may mga laman, na ang tawag ay HTF. After that, ipapasa nito ang init sa tubig. But alam natin na yung boiling point of water is 100 degrees centigrade lang. And under this parabolic trough, the heat transfer fluid can reach up to 400 degrees centigrade pero 100 degrees centigrade lang ang boiling point ng kaya ng water. Konting temperature lang ay pwede na mag-evaporate ito. But the question is, why use HTF instead of the direct system in which water is instantly turned into steam by the heat reflected by mirrors in solar thermal system or CSP? Because ang mga working fluids na ito ay may mataas na heat capacity. Maaari nito mapanatili ang mataas na antas sa init in a long period of time. Kaya ito ay CSP. Madaming HTF ay pinapainit sa mataas na temperature sa araw, kung saan ang intensity ng liwanag ng araw ay nasa pinakamataas. Pagkatapos, ito ay iniimbak sa isang masikip na vessel. Ito ay nagsisilbing reserbang power na maaaring gamitin sa maulap na araw when the sun's intensity is at its lowest or during nighttime where there is a totally no presence of sunlight. Next is we have different types of HTF or heat transfer fluids. Meron tayong air, water, molten salt, glycol-based, glycerol-based, and lastly, synthetic oils. Yung air water, sa panahon ngayon, hindi na ito ginagamit because air and water, hindi tayo makakuha ng reserve power. And nowadays, ito yung mga ginagamit na. Yung molten salt, glycol-based, glycerol-based, and synthetic oils.
The following characteristics are being considered on what type of HTF is to be used in a solar thermal power plant. One of these is operating temperature. For example, the temperature that the fluid can take that needs to be efficient for the power plant, the life cycle or lifespan of the fluid to be used for the power plant, heat transfer capability or the capability of the fluid to pass the heat to the water, heat storage aspect or the span of time that the fluid can store heat, overall safety. Like for example, there are fluids that are a bit harmful for people and to the environment, and other is when exposed to the environment reacts and that could be dangerous. Lastly, cost. Because big businesses like to cost cut and save their money for future purposes or for themselves. Note, the use of molten salt in parabolic trough system can heat the transfer fluid to 550 degrees centigrade. Has a better performance than a synthetic oil which can heat the HTF to only 400 degrees centigrade or less. Ayuwasa et al. 2017. Solar tower. This is another type of solar thermal system, and we are going to discuss solar tower. And like the other types of solar thermal system, they have the same system of operations, and they only differ on how they take energy from the sun. The setup of the solar tower includes an array of large number of computer-controlled sun tracking mirrors known as heliostats. The highlight of this topic is that the solar tower can concentrate as much as 1,500 times of the sun's normal intensity. This principle is like in a principle of a magnifying glass, that when you use the sun's ray of light through the glass and to a piece of paper, it can potentially burn it, but when you directly put the paper in the sun's light, it will not burn. The mirrors moves in a dual axis and are located at the ground level, which collects energy from the sun, then reflects it towards a receiver which contains HTF located at the top of the tower. The HTF is being heated at around 600 degrees Celsius, and just like in a parabolic trough, this HTF, through pipes, it goes to a set of heat exchangers. Then it transfers heat to the water, thereby generating high-pressure superheated steam, which is being used to turn a steam turbine. Based on the schematic diagram, this is how a solar power tower works. The rays of heat of the sun then gets collected and reflected by the heliostat. Next, it will be received by the thermal receiver at the top that contains the HTF or heat transfer fluid. Then the HTF will go to the heat exchanger, and there will be some that will go to a tight vessel to be preserved to be used at night.
Linear Fresnel reflector. So sa design na to is flat mirrors yung ginamit, hindi parabolic mirrors, kasi mas mura yung flat mirrors, and yung tumatama na liwanag sa flat mirrors is nare-reflect papunta sa fixed receiver na nasa taas pero hindi siya tower. So next yung figure and how it operates. So yung araw, yung heat tatama sa flat mirrors, and then magre-reflect sa absorber tube. And pag hindi naman tumama sa absorber tube, merong secondary reflector, which is yun yung magre-reflect papuntang absorber tube. So yung disadvantage nito is parang may naaaninuhan niya yung katabi niyang mirror kasi magkakadikit sila, and pag pinaghiwa-hiwalay yon is mas tataas yung cost, and yung very high temperatures are not produced as compared to a parabolic trough or solar tower, and therefore the efficiency is less. So sa figure naman na to, ito yung mismong kung paano siya mag-operate. So, ito, tingnan na lang natin. And ito, yung next figure, ito yung linear Fresnel reflector in real life situation. Next one is compact linear Fresnel reflector. Dito, dalawa na yung receiver sa gitna. So yung mga mirror na nasa ground, nasa baba, is meron ng sensor. Tapos sila na yung magde-decide kung saang receiver nila i-direct yung energy na na-absorb nila from the sun. So ito yung 3D build ng compact linear Fresnel reflector.
Parabolic dish. This consists of sets of flat mirrors combined to form a large parabolic dishes that is attached to a motor sensor which tracks the movement of the sun in dual axis. The collected energy from the sun is being concentrated to the PCU located at the focal point of the dish. The PCU consists mainly of the thermal receiver and Stirling engine. The thermal receiver, which is a heat exchanger, transfers its heat to the Stirling engine, causing it to reciprocate. The reciprocating movement causes the rotation of an electric generator. These dishes can concentrate sunlight in such better than parabolic throws, and the fluid run through them can reach temperatures upward of 750 degrees Celsius. Because of these limitations of size and the small quantity of fluid, parabolic dishes collectors are suitable for small-scale power generator, up to a few kilowatts. Stirling engine. Stirling engines can be hard to understand. Here are the key points. Every Stirling engine has a sealed cylinder with one part hot and the other cold. The working gas inside the engine, which is often air, helium, and hydrogen, is moved by a mechanism from hot side to the cold side. When gas is on the hot side, it expands and pushes up into a piston. When it moves back to the cold side, it contracts. Here is a diagram of a parabolic dish. Concentrator shell, elevation bearing, concentrator ring truss, elevation drive arc, switch case, azimuth drive, Stirling engine package, Stirling support structure, turntable, azimuth drive arc, and reinforced concrete rim foundation. The next one is an example of a Stirling engine. Here are some of the largest solar thermal power stations. First is the Warzazate Solar Power Station, which has the capacity of 510 megawatts, which located in Morocco. Has the type of a parabolic throw and a solar tower, which dated in 2018 and has an area of 2,500 hectares. Second one is Ivanpah Solar Power Facility, which has the capacity of 392 megawatts, located in USA, and is a type of a solar tower, which dated in 2014 and has an area of 1,420 hectares. The third one is the Mojave Solar Project, which has a capacity of 280 megawatts, which is located in USA and is a type of a parabolic throw, which dated in 2014 and has an area of 714 hectares. Fourth one is Solona Generating Station, which has a capacity of 280 megawatts and also located in USA and is a type of parabolic throw, which dated in 2013 and has an area of 780 hectares. The fifth one is the Genesis Solar Energy Project, which has a capacity of 280 megawatts, located in USA and is a type of parabolic throw, which dated in 2014 and has an area of 1,920 hectares. And the last one is a Solaben Solar Power Station, which has a capacity of 200 megawatts, which is located in Spain and is a type of a parabolic throw, which dated in 2012 and has an area of 301 hectares. is also one of the largest solar thermal power stations that is still under construction, which is named Mohammed bin Rashid Al Maktoum Solar Park Phase 4, which has a capacity of 600 and 100 megawatts, which is located in Dubai, UAE, and is a type of a parabolic throw and a solar tower, which dated in 2022.